Let's do a challenge question. This is going to be a tough question, so don't worry if you don't find it easy. The functions f and g are such that f of x equals 2x squared minus 1 and g of x equals 3 divided by x squared. The function h of x is such that h of x equals the inverse of f and g. Find h of x. So there's quite a lot to unpack here. We're going to start by finding the composite function f of g of x. So how are we going to do this? Well, if you remember, we take f of x and we're going to substitute g of x into it. Now we have an expression for our composite function, we can start to think about how we might find the inverse of it. We can remind ourselves of the three-step method that we wrote down previously. So we can start by swapping out the function for y. We can then move on to the next step, which is to swap y and x around. And finally we can move on to the third step, which is to make y the subject. Now the algebra is going to get pretty tricky here. So we'll start by moving that minus 1 over to the other side of the equation. We can then divide both sides by 2 and then square root. Now on the right hand side we have the y squared on the denominator, so we're going to need to take the reciprocals of both sides. Basically we're going to just flip both fractions. And then finally we can times both sides by 3 and then take the square root again. So finally, just to tidy up, I'm going to take that square root of 3 inside the fourth root, making it a 9. And there we have it, we've worked out the inverse of the composite function fg. From the question we know this is defined as the function h of x. Now that's about as hard as these questions are going to get.